Okay, so we are going to talk about the blood and vasculature in this chapter, and we are also going to talk about the circulatory system as a whole. So this works off the same word list that you had for our heart chapter. So no new word list for this week. Next week for the lymphatic and immune system chapter, there is an updated word list. But for right now, we're off that same word list from week 5. Okay, so what is actually in the blood? The primary component is going to be the erythrocytes. So these are red blood cells. So cyte is our suffix for cell. Erythro is our combining form for red. And so their job primarily is to carry oxygen. So they have hemoglobin, which is a protein that allows oxygen to bind. And that's how our red blood cells carry oxygen. You'll see our red blood cells are this disc shape. They're considered a biconcave disc, so they have this little depression on either side of them, and they have a very flexible cytoskeleton or structure because they need to be able to fit in all of our little vessels and not get stuck. Our next one is thrombocytes. So this is our term for platelets. So again, cyte is our suffix for cell, and then thrombo is our combining form for platelet. And so our platelets' main role is contributing to forming blood clots as needed. Leukocytes are our white blood cells. So again, cyte is for cell, and then leuko is our combining form for white. So our white blood cells are our immune function. So we'll talk about those a little bit more in our next chapter. In the parentheses there is just a few examples of our white blood cells. And then everything else that's in our blood includes water, some dissolved proteins, some glucose, some gases, and hormones, all within the bloodstream. So our 1, 2, and 3, our erythrocytes, our thrombocytes, and our leukocytes, our red blood cells, platelets, and white blood cells are what we consider our formed elements. So if you look at this picture at the bottom here, this is what a blood sample looks like if it would be spun in a centrifuge or left to rest so that it can separate. And so when it separates out, you'll see we have about 45% of it is our red blood cells. Only about 1% is our white blood cells and platelets. We call that the buffy coat. And then the majority is our plasma. So plasma is the fluid portion of the blood. Plasma is the fluid portion. So that has proteins, glucose, gases, hormones, all this stuff, all the other stuff is dissolved within the plasma. Okay, hematopoiesis is a term you should be able to kind of figure out based on your word parts. So poiesis is our suffix for formation or generation, and hemat is one of our words for blood tissue. So hematopoiesis is the formation of blood cells. So you do not need to memorize this tree here by any means, but it shows you that we start all up here with a stem cell. And this is a blood cell specific stem cell, so it's slightly specialized. And then from there, we specialize into a few different types of white blood cells, or all these here. We have our thrombocytes or platelets. They're called platelets because they're little tiny pieces that have broken off of a megakaryocyte cell. And then you see we have our red blood cells or our erythrocytes here as well. So like I said, this is more of a nice to know slide. Don't feel like you need to try to memorize this tree. You will not get tested on that aspect. All right, let's just go over a few terms related to the blood. So our first one we're going to talk about is a poikilocyte. So a poikilocyte is an abnormally shaped red blood cell. So you see we had our nice little, oops, sorry guys. We had our nice discs on that first slide. And then in this slide, right under poikilocyte, you can see that those are not perfect little circles. So poikilocyte is our abnormally shaped red blood cell. Hemoglobin, we mentioned that earlier as well. So that is a protein or a molecule that allows for red blood cells to carry oxygen. So each red blood cell has 4 hemoglobins. And so each red blood cell can carry 4 oxygen molecules. Let's go back to the left side over here, a phagocyte. So this is a category of white blood cell that includes about 5 of them. So cyte for cell, and then our combining form phago here means to eat. So a phagocyte is a cell that is going to engulf or eat foreign material, dead cells, debris, that kind of stuff. A macrophage is a special or a certain type of phagocyte. So this is one example of a phagocyte. So macrophages and monocytes are some of our most abundant phagocytes within the bloodstream. I'll move across the bottom here next. You see we have 3 different blood samples here. So this first one looks like the one on our first slide. That's our normal blood sample. And so you see we have our red blood cells here at the bottom. We call that the hematocrit. So crit means to separate, hemato means blood. So hematocrit is our red blood cells separated out. So if they give you the hematocrit percentage, they're giving you just the percentage of red blood cells. So underneath here, it just is pointing out that there is a different normal percentage for males and females. So males have a little higher blood volume, so they should have a bit higher percentage of red blood cells. You see the Buffy coat there, that's our white blood cells and platelets, just a small percentage, and then plasma is our fluid portion. So our next term, sorry, it keeps popping up down there, but our next term here is hyposiderosis. So let's break this one down. Osis is our suffix for abnormal condition. Hypo means deficient or not enough. And then SIDER, cider, that is a new root for iron. So hyposiderosis would be an abnormal condition of deficient iron. Another term for that would be anemia. So that's going to result in a decreased hematocrit percentage, meaning we have less blood cells within our blood sample, or less red blood cells specifically. So iron is a key component to hemoglobin. So without iron, we can't create hemoglobin. Without hemoglobin, we can't make up more red blood cells. So we see a decrease. So obviously that's not a good thing because that means we can deliver less oxygen to the tissue. And then vice versa, we have polycythemia. So this is actually going to be an elevated hematocrit. You see in this case, we have a decreased percentage of plasma or fluid and an elevated hematocrit. And so this is pointing out leukopenia. So leuco is our combining form for white, penia, again, meaning deficient. So leukopenia, and penia is really deficient as it relates to the bloodstream. So this is going to be not enough white blood cells in our sample. Moving up, hypoglycemia. So emia is going to be an abnormal blood condition. Hypo is going to be not enough. And then GLYC is going to be our root for sugar, so glyc. So hypoglycemia is not enough blood sugar or a low blood sugar. Thrombocyte, we saw that one earlier. We said that's a platelet. So this little piece here is a thrombocyte. And so that leads us right into here. A thrombus or thrombosis is an abnormal blood clot. So thrombosis is an abnormal condition of a clot. This clot itself is a thrombus. So it's made up of platelets. So this is a thrombus. If a piece breaks off of our thrombus, it becomes an embolus. So you can see a thrombus causes an issue by itself because it's blocking blood flow. So there's blood that's getting by, but it's at a decreased rate. But it's really scary because if the blood that's passing by is enough to break off a chunk, now we have a embolus that's traveling through our bloodstream. And you can see at the bottom of the picture there, if it gets trapped in a smaller vessel, it can completely block our blood flow, which is going to be very problematic for whatever is on the other side that is relying on that blood flow for oxygen and nutrients. So our circulatory system is one giant loop, more or less. So here's a very simplified version of that loop. So you see we have arteries and veins. So the way to remember this is that we have arteries away. So arteries are going to carry blood away from the heart towards the body's tissues. Veins are going to carry blood back to the heart from the body's tissues after it's already been utilized. So we start with large arteries. As our arteries get smaller, we call them arterioles. And then our arterioles are eventually going to blend into our capillary bed. So the capillaries are the smallest vessels. They're kind of laying right against the tissue. And within this capillary bed network, this is where a lot of our gas, hormone, nutrient exchange is going to happen between the blood and the tissues. So these are going to be super thin, tiny vessels. So it's easy for the blood or fluid to flow out and in. So as it comes into the arterial side, into the capillary bed, the tissue is going to start stealing what it needs from the blood. And then we get to our vein or venule side where our tissues are going to put back in their wastes and any excess fluid. So we have the vein side of our capillary. So we're going to have our venules, our tiny veins, and they're going to eventually turn into bigger veins that lead back to the heart and the superior and inferior vena cava, remember, are our last veins before we empty into the right atrium. I don't need you to try to memorize all these terms here. What you should know here is that our smooth muscle layer of our arterial wall is much thicker than our smooth muscle layer in the veins. So our arteries have the ability to change shape. So they're more elastic than our veins, but we need muscle to be able to do that. So our arteries dilate or open up and constrict or get more narrow to regulate blood flow and also regulate temperature. So that's one other difference I wanted to point out with the smooth muscle. Our arteries are also under much higher pressure than our veins are. Whoa. So our arteries are under much higher pressure than our veins are. So they have a bit more structure to them to be able to handle that pressure of blood coming from the heart. Okay, a couple other terms to go over here related to this chapter. So a very common disease, unfortunately, in this country is atherosclerosis. So sclerosis is a suffix we've seen before. That means hardening. And then athero is our combining form for plaque. So this shows a normal artery. The endothelium is the inner lining, and the lumen is the opening. And so nothing should really be sticking to that endothelium. We have a nice open area for the blood to flow. What can happen with excess fat in the diet and other things that should not be in the body is that they start to stick underneath the wall of this endothelium. So our endothelium gets damaged, and then lipids, calcium, and debris end up sticking underneath that wall and pushing it up. So now we have much less of an opening. And so now we have a narrow artery caused by atherosclerotic plaque. So atherosclerosis is this narrowing of an artery due to this plaque buildup. So one of the risk factors for atherosclerosis is hyperlipidemia. So remember we said our suffix emia was an abnormal blood condition. Hyper means excessive, and then lipid stands for lipids or fats. A hemangioma. So let's break it down. Suffix first like usual. Oma is tumor, and then hemange is going to be a blood vessel tumor. So a tumor of a blood vessel. So this is a hemangioma here, where you have that growing of excessive blood vessels in that one area. So it's not a malignant tumor in this case, but it's still considered a tumor. So that's a hemangioma. Angiography. So graphy is our suffix to measure or image. And so this shows vessel imaging. So what they'll typically do is take some kind of radioactive dye that is safe for the body. They'll inject it so that it spreads throughout the bloodstream. And then when they go to image it, the vessels will light up with that contrast in them so they can see them more easily. Then our bottom half here, so peripheral arterial disease. So this is caused by a buildup of plaque. So this is another consequence of hyperlipidemia. And so like we showed in our atherosclerosis diagram there, when we have that buildup, we're going to end up with decreased blood flow. If we get decreased blood flow, that means the muscles that are farther down the chain are not going to get the proper oxygen and nutrients. And so they are going to either begin to die off, or they're going to just be very uncomfortable when they have to do work. So a lot of times with peripheral arterial disease, you'll see it in the lower legs, and people will complain that they start getting calf and foot pain as they walk because their muscles are being starved of oxygen. Down in the bottom left here, critical limb ischemia. So emia, again, that's that abnormal blood condition. Isch is our root for blockage. So ischemia means an abnormal blockage of blood flow. So critical limb ischemia is going to mean we have a complete blockage of blood flow to an area, and so tissue is going to start dying. So either we have to restore blood flow quickly, or we're going to have to amputate the area that's not getting properly perfused. Okay, last one here. This is just showing the plaque buildup again. So this shows some plaque buildup, and clot is starting to form. You got fibrin and platelets. We start to get more of a clot, and then eventually we have a full clot blocking the entire artery. Okay, now it's just time for some practice. So go ahead, pause the video here now. Don't go to the next slide quite yet, because that'll give you your answers already. And when you're ready, go ahead and check your work on the next slide. All right, see how you did. The one thing that I want to point out is the difference between arteriosclerosis and atherosclerosis. So in that case, sclerosis is obviously our suffix for hardening in both cases, but arterio is just going to mean hardening of arteries in general, where athero is going to point the finger at the plaque for being the reason why that hardening is occurring. All right, this time we're going to go the opposite direction. So we're going to start with the word, and you go ahead and provide the definition. So go ahead one more time, pause the video, and restart it when you're ready to see the answers. All right, there shouldn't be any major surprises here. So just check what you had there. All those should be pretty straightforward. And I think that is our last one for this presentation. So that is the circulatory system. So not quite as much as our heart and lymphatic chapter. If you have any questions on any of the stuff we discussed, please let me know and take a look at the Unit 3 review activity to know exactly kind of what to focus on for concepts in this chapter. And as always, keep studying that vocab.